Guys, I'm heading out toward the water here. Checking out a few beach houses. Two are on the water. One's in a town called Southport. So I'm checking them all out.
Beach. I'm checking out those Goodman systems. They have a 100-pound suction, 370-pound head pressure. We're running in heat mode. So heat mode pressures run a little bit differently than cooling mode pressures. Usually get a little bit higher head, especially when it's a little bit warmer outside. Because we're back in the 50s right now. So it's a little bit warmer. The warmer end of the heating spectrum anyway. You can see we've only been out here for about a year and a half, and the outside the cabinet's starting to fall apart. It doesn't bode well for a long, healthy life. I replaced the two copper lines and coated them in Plastidip, so they're still relatively good. There's a couple spots that have broken off there. Might have to touch up, but just checking the heating pressures. This unit on this side, the reversing valve and contactor wires were wired together, and I'm sure that's some sort of maintenance guy fix for something. So I had to take those apart. The thermostat upstairs wasn't sending the proper signals, the Ecobee stat. It wasn't sending the signal for the blower at the proper time. So that has to be changed out as well. Unfortunately, I don't have a thermostat, so I'm actually have to go to Lowe's and buy one. But I'm going to another house, so I'm going to run by there on the way to the other house. So that's what we're looking like so far. Just make sure the other system's running properly.
Brown child in the way, sing a song for me. I've heard so many songs, but none of them for me.
Some interesting stuff going on with these ground wires. We have our ground wire here coming out of the bottom of the panel, running down. We have another ground wire coming up here, going I don't know where. A little strange. But we're going to get into this pain unit right here, check it out and make sure it's good to go. Here's the inner workings of our pain unit. We have our compressor, pressure tap, accumulator, reversing valve. We have our two distributors really close. So that short section of pipe with the dryer in it, it's pretty much the only place where you're going to get your subcooling measurement. We have our wire coming from the panel here to power up the compressor section. You can see it right there. Wire's a little bit big, but there's a separate circuit to do the heat strip. Bigger is better than smaller. We have a 30 amp breaker being used. The 50 is not. We're going to test those out. Test the capacitor down there, see if it's good. And then we're going to start the unit up, see how she runs in heat. We have our I-manifold probe, high side on the discharge line. The low side here is on the suction line returning to the compressor. I have one temperature probe for superheat on the suction line connected to the low side probe. The other side of the low side probe is connected and just coiled up. That's for outside air. We have one side on the high side right there, connected over here for subcooling. I'm going to take the two probes here inside, put them in the return and supply grills, and I'm going to start the unit up. Guys, running a 320/102 right now, 16 degrees of subcooling, 14 degrees of superheat. I'm going to let her run for a few minutes because she just got started. I have the heat strip breaker turned off in the panel over there because I don't want to run the strips yet. I want to get a sense of the heat rise without the strips. We're not going to get any BTU calculations right now because our return air is very cold. Let's take a look. Return air is 58. That'll come up as we run for a little bit, but it may not come up far enough. So we'll let her run. I have a feeling she's going to be just fine. But that's why we check them out, just to make sure. We'll test the heat strips here after about 10 or 15 minutes. Guys, we're running a 350/110. Our pressure will still likely rise quite a bit. 35 degree split, which is pretty good. 17 degrees superheat, 18 degrees of subcooling. We'll let her go for a little bit longer. We haven't tested the strips yet, but heat pumps take a little bit to get going. They'll start with lower numbers and gradually build up. Here's one of the biggest problems I see with the iManifold app right now, at least for Android. If you got Apple, which is what everybody's recommending now, you won't have an issue. But I got it where it'll run for a while, then it'll just lock on this certain number. I have to hit the button, and it will catch up again. It'll unfreeze if I touch the screen. But if I leave it like this, after about a minute or two, it'll stay frozen until I tap it again. So kind of a pain in the butt. My iPad, I don't know where I put the charger, so it's dead, so I can't use it today. But I'll definitely pick up a new charger because this is kind of, it's ridiculous to have to do that over and over again. So we have our meter hooked on the strip heat feeder. I'm gonna hit the breaker, and we're gonna see how many amps we're pulling. Should be around 20 amps. Might as well not shut off the camera. Immediately we have 19.5 amps right there. So we're gonna go take a look inside, smell the stink of heat strips, and we'll be back out in a minute. Guys, when your heat strips come on for the first time, you're likely gonna smell a little bit of burning off of whatever residues on them, whatever dirt and dust has accumulated on the heat strips over the summertime. It's normal. It should only last a few minutes and should be over with. If you have any prolonged burning, that's definitely an issue, and it should only happen the first time you cut the heat strips on. So just keep that in mind. You know, you're going to smell it for a couple minutes, it's going to burn off, and it should go away. If you have an hour later, you still smell it, something is wrong, and everything should be shut down. My return side, a manifold probe, is just sitting right there above the return. The supply side is sitting there right on top of the grill. What I did is I put it over here on this side of the grill because the flex comes in at an angle like this. Usually the air movement brings it over here like that, so a nice little flow across the probe. As you guys can see, we have 0 amps. Now we're gonna wait just a second here. This is on a heat strip circuit. We're gonna hold tight for just a minute. 0 amps, let's keep on. Now we have 19 amps, so they're coming on and off. Now when I put my leads across the switch and did voltage, to see if there was a voltage drop across the switch, meaning was the switch opening and closing, it was not. So we have an issue with the limits. So we're going to shut this down and take a look on the inside of the machine and see if we can't change the blower speed and see what we can do to sort of get these limits from opening and closing. All right, looking down at our wires here, we have an ECM motor. It's an X13 motor. Has 3 speeds coming off of it, low, medium, and high. I have high speed now jump to these wires here, which are green, but are actually the Y signal. They mate into the ones that are on the side of the contactor there. Those are brown, but they're not common. The common's on the other side. It's kind of interesting because commons over the years have been typically blue, brown, or black, and they've used a lot of those colors throughout the cabinet here for things that are not common. So it's interesting. I took down the low speed tap and put a stopper on it. We have a wire here, a medium speed tap with the white coming to it from the field connection, and I'm going to say that when these two are rolling, it gives precedent to the Y signal, but we're going to see what happens when we turn it on because this is permanently in place. So I'm thinking that when you have an emergency heat signal, it'll run on medium speed. So we're going to try that out, see how that works, see if that improves our situation. Guys, as you can see, we have our fan set up on high speed now. We put in, or I put in a thermostat, just like an outdoor thermostat. And what I'm going to do is I'm going to keep the heat strips from coming on from the thermostat because they're coming in on this white wire here. Then they're going up on this black wire into this control. And it only lets the power through below 40 degrees. So below 40 degrees, it'll keep on coming down here. Then it'll travel over to the heat strip relay. During defrost, the power comes from here, so it'll travel through here to the wire nut and back over here no matter what temperature it is. So defrost won't be affected, which is how you want it. So I'm gonna do it that way and then test this switch. I can adjust. Right now it's set on 40 degrees, but if you turn it, you can set it up higher. If you turn it the other way, you can set it lower. Have it kind of mounted upside down just from the configuration of the screw holes that were in there. So let me turn it on and see what's what. I just have my amp clamp here, 0 amps. I'm going to adjust my temperature up till we get past our temperature of around 60 degrees outside, and we should have heat strip operation then. Alright, I'm adjusting the switch now. It clicked in. We have our heat strips come on. Have normal operation there. So what we're going to do is we're going to set it back down and see if they go off. And they do shut off, so we're going to put it down on 40 degrees. And that's just so they won't run when it's warmer outside. Save them some energy, let the heat pump take over. Plus, make sure we don't limit out all the time going back and forth. Doesn't appear to be an airflow issue. I don't see where there would be, but just a little bit too much heat. The heat strips are mounted behind the blower, so it's kind of an awkward location. I don't really know what the logic is there, except for saving space, but we're going to go with this. It'll serve them well, and hopefully we'll have any more issues with the limit triggering. It sucks to run out of a thermostats when you have only one supplier nearby.
If he came down from the mountain and asked you right now, how's your life going?
K-type clamp thermocouple over here. 66 degrees right now on the line. We have a pressure around 105, which says the temperature between like 32 and 34 degrees. So we have around a 30-degree superheat. Our target was around 25, so we're a little bit off of that, but still pretty close. Close enough where I'm not going to adjust anything. Plus it's cold outside today. It's not really a good day to do that sort of thing anyway. So just want to double check, see if we're in the ballpark, which we are. I'm going to turn the machine into heat just to make sure every function is working. Then we'll move on to our final house of the day.
All right, gentlemen, heading down the beach for the final house. I installed this system last year, I think it was. Last year in the summertime, so it's a little bit over a year old. Comfort Maker coastal system. So we'll take a look at this one, see what's up with it. Hopefully nothing. And mosey our way back 50 miles north.
Our Comfort Maker air handler. We're going to go ahead and get it all squared away, run it. It's on a zone system. Old Weather Maker 2-zone system. They kept a lot of the stuff that was in place. There is a mass of crap behind there. What you have is segments divided up with duckboard and all sorts of ways. But all that the finances allowed was to change the system. So we kind of had to be very careful. And parts of it were falling apart. I had to put them back together. It was hellacious. You see this. But there you go. Comfort Maker.
You can see what the salt air does to some of these lines. I mean, these lines are just over a year old. We're going to have to coat those lines too. Probably won't do that this time. First of all, I don't think I had any plastic dip when I last checked. But I might do it in the spring. The electrical kind of torn up right there. It's crazy. It doesn't take very long at all. But you can see the ICP. If you look at it out there in the light. The coastal unit looks pretty good after about a year of service. A lot better than the Goodman. No judgment. You can see the capacitor here. Looks like there's more damage rust-wise to the capacitor so far than anything else. Now it's not a whole lot, but you can see that this is a capacitor that's, you know, the unit itself was a 1417 serial number, meaning it was built in April, or right around April, May last year. It was installed early summer last year, and you can see it's already rusted up quite a bit. But we're going to check the capacitor, start the system up, because we got ECM motor upstairs, no capacitor there, so this is the only capacitor we need to check. Then we can start things up and see how she runs. Guys, right now we're running an air conditioning, 245 over 88, getting close to target. We're still coming up. See, our target suction pressure is 93. We're at 88, so we're already pretty close on that one. But we should come up in the range here, probably go a little bit higher than the 93 once it's all said and done. 7.8 degrees of subcooling, 25 degrees of superheat. See, that manifold is now frozen. Ready to free it up. Oh. Let's free up the eye manifold by pressing it. Ooh. Here we are. See? So we're right on target suction pressure. Head pressure's coming up into range. Subcooling's good. Superheat's coming down. Not really great conditions for testing this. In fact, our return air is 61 degrees, which is kind of chilly. Kind of nippy. Outdoor air is 69 now, so it's warmed up a little bit. 74, 47 on the suction line. 64% relative humidity and 61. Let's see if our rule of thumb will work today. I don't know. It's kind of cold outside. Rule of thumb at 64%, we're looking at being 15, 16 degrees, somewhere in there. Let's see performance. That's not it. Well, temperature split's 14 right now. Well, we're too cold to do the estimated because just the return air is so cold, but we are still pretty close and we're still climbing up, so not too far away. We'll let it run for a little bit, guys, and we'll switch it into heat. Pressures are looking pretty good for this extreme condition, the cold temperature AC. We're operating below freezing, but that is our target because it's so cold inside and it's so cool outside. That's what's going to happen. Head pressure is getting a little bit closer to the target, but we're going to stay a little bit shy of that. About to turn on the heat, make sure it's squared away. Make sure it's happy. Guys, as you can see here, we have a 159 over 129. Now there's nothing wrong. I just have my hoses set in air conditioning and never moved them over for heating. And since this is ICP / Carrier, Bryant, Grand Air, etc. Payne, you have to move that hose over to the discharge line to get your high pressure because you have an orifice right there at your liquid line, as we would call it in cooling. So when that liquid comes back and hits that orifice, we get this pressure over here, 159. But I wanted to show you this so you can see what kind of drop we have in between the orifice outside, this is the heating orifice we're talking about, and the heat pump charging port near the compressor. So there's 30 pounds of drop in between those two areas. Just thought you guys would like to see that because for a long time I wasn't aware how much drop there was, and now you can sort of see it right here in front of you. So I need to switch mine over to the discharge line so I can get my high pressure. But you know, it looks like we're pretty good from our suction pressure right here. It looks like we're all done for today. I'm sitting here with the ICP. The ICP is running well. You can hear it. You hear that special tenor of the compressor. It's hard to hear sometimes unless you hear it running below a certain PSI and above it. At about 400 PSI, you see the tenor change. This is R410A. It's in heating. It's pretty warm outside today, so we're going to run a high head, which is fine. We got about 445 pounds of head pressure, which is actually within range for what we should be, just because it's so warm outside and it's warming up inside the house as well. So, but thought I would let you hear the tenor. We're all done for today. I'm heading back to my home, 50 miles away. Oh yeah, after I get some. Guys, I got all done with my service calls. Got the phone call, my wife is sick, so I gotta head home, try to bust some ass and get to the soccer field so my son can have his soccer practice tonight. And it so happens that, luckily for me, my son's practice is also where my kids go to school, so I can scoop them up and they can hang out while we're going. But it's 5:04. I have to get home. I'm about 5 minutes away from home. And the school's right around 15 or 20 minutes away, and it's 5:30 practice, so we ought to be skinning right in there right in time. So wish me luck, Godspeed. I'll see you guys on the next one.
Is she rolling down the boulevard with her hands in her pockets, trying hard not to get carried away? She stayed the night in her boyfriend's bed. She woke to find he'd already left and gone to work. She's almost worked one whole year